Okay, so you guys should have already watched the Edpuzzle video about the basics of moles and kind of what they are and why they're useful and how we use them in chemistry. Um, we're going to take that a little bit further and talk about molar mass and what that means. But before we get too far into that, we'll just go back over the basics real quick. So a mole is just a term for a quantity. So if you have a pair of something, that means you've got two of them. If you have a dozen, that means you have 12. If you have a mole, it means you have 6 sextillion, right? A ton. 6.02 times 10 to the 23rd. And that number is just like so blowingly huge that it doesn't even really bear thinking about too much. Just know that it's a very, very large number. Right, and it's referred to as Avogadro's number after the guy who kind of came up with this concept. And the reason that this is useful for us, the main way that we're going to use it, is because it allows us to convert between the number of particles in a sample and the mass of that sample. Right, so this number seems kind of arbitrary when you first look at it. Like, why did they choose this giant, huge 6 sextillion particles per mole number? But the reason is because it does something really cool with the atomic mass. So if we look on the periodic table and we find the atomic mass of any of these elements on the periodic table, it's going to be given to us in terms of AMUs, which are atomic mass units. It basically just means how many neutrons and protons are in that atom. So that's, trying to weigh something in terms of AMUs, neutrons and protons, is pretty much impossible. It's just so minuscule that we don't have enough precision with our scales and instruments and anything like that to do it even in like the most high-level labs. What we can do though is weigh things in grams. That's something that even like the little kitchen scale you might have at home can do. Alright, and what's cool about moles is it allows us to convert from AMUs to grams relatively easily. So the reason they chose that giant 6 sextillion, or 6.02 times 10 to the 23rd number for how many particles are in a mole is because that is the number that makes the weight of 1 mole in grams equal to the atomic weight, or the atomic mass, of that element. So for example, if a sodium atom weighs 23 AMUs, it has 23 protons and neutrons, then 1 mole of sodium will weigh 23 grams. Right? And it makes it really, really easy for us to kind of convert back and forth between, oh, I have this many grams of this substance, that means I must have X number of moles of particles of it. Right? So, just for example, if we're looking at these 3 elements and we want to know how much 1 mole of them will weigh, all we've got to do is pull up our periodic table, which for some reason is not showing up. There it is. Pull up our periodic table, find them on the periodic table. So if we're looking for carbon, we're looking right here, and find its atomic mass, which is this number on the bottom that tells us how many protons and neutrons the average carbon atom is going to have. So if that's its atomic mass, that's how much 1 mole of it is going to weigh. So the molar mass of carbon is 12.011 grams per mole. Right? Same deal with sulfur. Go find sulfur on the periodic table. You find its atomic mass of 32.06, and that tells you that 1 mole of sulfur is going to weigh 32.06 grams. It's that same deal with copper. For any element on the periodic table, it doesn't matter which one. Whatever its atomic mass is below the symbol, that's how much 1 mole of it is going to weigh. So for copper, you have 63.546 is the atomic mass, so copper weighs that many grams per mole. It's real simple. Alright, the part where this kind of gets a little tricky is that you can also use it to find what's called the molar mass of a molecule, not just individual atoms. So the molar mass of any given molecule is the sum of the atomic masses of all those individual atoms. So water, for example, that has a formula of H2O, 2 hydrogens and 1 oxygen, would just have the molar mass of all those atoms added together. So you find the molar mass of hydrogen, which if we pull up that periodic table again, so the molar mass of hydrogen is 1.008. So you say down here 1.008 times 2, because we've got 2 of them in the formula. That's what that little subscript means. And then to that you're adding however much this oxygen molecule weighs. So you find oxygen on your periodic table, you take its atomic weight of 15.999, and you add that in there. So altogether, when you add them up, you get 18.015 grams per mole is the molar mass of water. So 6 sextillion, or 6.02 times 10 to the 23rd water molecules only weigh 18 grams. So that kind of gives you an idea of just how tiny those water molecules really are. Alright, so that one was relatively simple, but you can also have, some more complex compounds. Like if you look at sugar, for example, sugar is a little bit longer formula. You've got C6H12O6, so 6 carbons, 12 hydrogens, and 6 oxygens. So just like we did before, we're going to find each individual atomic mass for these elements, multiply it by how many of them we have in our formula. So here, carbon weighs 12.011 per atom. We've got 6 atoms in this formula, so we do 12.011 times 6. The hydrogen, same as it was before, is 1.008, and there's 12 of them in our formula, so it would be that times 12. And the oxygen, again, is the 15.999, and in this formula we have 6 of them, so we're multiplying that by 6. And then we add all of that together to get our total molar mass of 180.156 grams per mole. So sugar is about 10 times heavier per molecule than water is, right? If you compare the two. Alright, so that's basically all there is to it today. You guys are going to have a homework assignment where you're going through and finding molar masses for a bunch of different elements and compounds and stuff like that. For the most part, they'll be relatively simple, like water and sugar. There might be a couple on there where I throw in like polyatomics or something in that kind of vein where you've got to worry about parentheses and doing that. So if you get stuck on any of those, just let me know and I can help you out. But that should be what you're doing today. And if you need a link to the periodic table, it's right at the end of this PowerPoint that will be posted on Canvas, or you can also just type in p-table into Google and it'll take you right to it. Okay, so let me know if you guys need any help.